Let's continue with number 5, which is a definite integral. We're going to solve it using partial fractions. So first of all, we're going to factor the denominator, which will be x plus 1 times x plus 2. We need two numbers. When we multiply them, we get 2, and when we add them up, we get 3. So those numbers are 1 and 2, so we have the first fraction with the denominator x plus 1, and the second one with the denominator x plus 2. We set a here, b here, and in order to have this denominator, we're going to multiply the first one, both of them with x plus 2, and these ones x plus 1. So the numerators, which is x minus 1 for the left one, and a times x plus 2 plus b times x plus 1 will be the same. We will keep the left one, and we multiply the right one. Ax plus 2 times a plus bx plus b, and then we would factor out x. So we're going to have a plus b times x plus 2a plus b, and the coefficient of the x of the left side, which is 1, is equal to the coefficient of x of the right side, which is a plus b, and the constant on the left side, which is -1, is going to be equal to the constant of the right side, which is 2a plus b. Solving this system of equations, we're going to have a equals -2 and b equals 3. If you want to know how, the simplest way is to multiply one of them by a -1. So if you multiply by -1, a will be deleted. You're going to have a as the first answer, and then plugging back a, you would have b as 3. So the given integral is going to be 0 to 1, a, which is -2 over x plus 1 dx, plus the integral from 0 to 1, b, which is 3 over x plus 2 dx. So we can bring out -2, integral of 0 to 1, 1 over x plus 1 here, dx, plus we can bring out 3, so 0 to 1, 1 over x plus 2 dx, and these are going to have ln as the answer. So -2 ln of absolute value x plus 1 plus 3 ln of absolute value of x plus 2. 0 to 1 here, 0 to 1 here. We don't need to write c because it is definite. So the answer is, if you plug in 1, you get -2 ln of 2 plus 3 ln of 3, minus, if you plug in 0, you get -2 ln of 1 plus 3 ln of 2. We know that ln of 1 is 0, so altogether we would have -5 ln of 2, because -2 is here, and minus 3 would be -5, plus 3 ln of 3, which is the term that is here. Or you can write it as ln of 2 to the power -5 plus 3 plus ln of 3 to the power 3. And with the help of laws, we can write it as ln of 27 over 32. Let's move on to number 6. So number 6. It's also going to be partial fraction, but the point is, in this one, the degree of top is more than the degree of the bottom. So in these cases, first of all, we would divide them algebraically. So x cubed minus 4x minus 10 will be divided by x squared minus x minus 6. So we would divide the highest power, the highest degrees x squared divided by x cubed divided by x squared. We would need just x here. We multiply x with all these terms here, and we would write the answers here with a negative, with the opposite. So x multiplied by x squared is x cubed, but negative. X multiplied by negative x is negative x squared, but we would write it as positive because this line is going to be subtracted by this line. And x multiplied by negative 6 is negative 6x, but the opposite is positive. So these two will be canceled, and we're left with x squared minus 4x plus 6x, which is plus 2x minus 10. Now, x squared divided by x squared is 1. So plus 1 here. Now multiply 1 by all these terms and write them here positive, negative, I mean opposite. Negative x squared plus x plus 6 here. So these will be gone. 2x plus x is 3x minus 4. So the given integral can be written as the integral of x plus 1 dx plus the integral of the remainder, which is 3x minus 4, over x squared minus x minus 6 dx. We know what the integral of x plus 1 is. That would be x squared over 2 plus x, but we need to find this integral. This one is going to be partial fraction. If we factor out the denominator, that would be 3x minus 4 over x minus 3 times x plus 2, because we need two numbers that if we multiply them together, we get negative 6, and if we add them up, we get negative 1. Those numbers are negative 3 and 2. So first fraction for x minus 3 with a here, and the next one x plus 2 with b here. We know that we're going to multiply the first one by x plus 2, and also here, the second one by x minus 3, and also here. So the left numerator is 3x minus 4. The right one is a times x plus 2 plus b times x minus 3. So 3x minus 4 will be equal to ax plus 2a plus bx minus 3b. We're going to factor out x. That would be a plus b times x, and the constant, which is 2a minus 3b. So we have to have a plus b equals 3, and 2a minus 3b equals negative 4. Solving this system of equation, it gives us that a is going to be 1 and b is 2. So we would plug them back here, and we say that the integral, this part, is going to be the integral of 1 over x minus 3, because a is 1, dx, plus the integral of b, which is 2 over x plus 2 dx. So we already found the first part, and we know that integral of 1 over x minus 3 is ln of absolute value of x minus 3. We can bring out 2, and integral of 1 over x plus 2 will be ln of x plus 2 here. And since it is indefinite, we would write plus c at the end. Also, you can use laws to combine these. Number 7. Okay, number 7 is x squared plus 2x minus 1 over x cubed minus x. So this one, the degree of numerator is less than the degree of denominator. So we can write it as x squared plus 2x minus 1 over, for the denominator, we can factor out x and we're left with x squared minus 1, which is the same as x squared plus 2x minus 1 over x times x minus 1 times x plus 1. Because we need to have factors that they cannot be reduced. So if we keep x squared minus 1, it is not correct because we can factor x squared minus 1. Now we have three fractions, x, x minus 1, and x plus 1, a, b, c here. So again, we would keep numerators. X squared plus 2x minus 1 will be equal to a multiplied by x minus 1 times x plus 1 plus b times x plus 1 and c times x minus 1. You can either multiply a, b, and c into the following parentheses, or you can plug in some numbers. I prefer to plug in numbers. So let's say x is 0. If we plug in 0 on the left side, we would have -1. And for the right side, we only have the first term. We don't have the second one and we don't have the third one. So if you plug in 0, the first parenthesis will be -1, the second one will be +1. Altogether, you have -a. It means that a is equal to 1. X equals 1. Pick another number. We prefer to pick numbers that make some of these terms 0. So if we plug in 1 on the left side, we would have 1 plus 2 minus 1, which is 2, equals, for the right side, we don't have the first one because it will be 0. We don't have the last one. We only have the middle one. It will be, if you plug in 1, you get 2b. So b will be 1 here. For the next point, I prefer to use -1, but you can pick any number. If you plug in -1, left side will be 1 minus 2 minus 1. It means that you would have -2 as the answer. And if you plug in -1, you don't have the first one, you don't have the second one, but you only have the third one, which is -c. So if you plug in -1, you have -1 here and -2 here. Altogether, it will be 2 times c. It means that c is -1. Now, the given integral is going to be the integral of a, which is 1 over x dx, plus the integral of b, which is 1 over x minus 1 dx, plus the integral of c, which is -1 over x plus 1 dx. We know that integral of 1 over x is ln of absolute value of x. We know that integral of 1 over x minus 1 is ln of absolute value x minus 1, and we know that this third one is ln of 1, the integral of 1 over x plus 1 with a negative here would be negative ln of absolute value of x plus 1 plus c. And you can use log laws. These are multiplied because they are added to each other, and this next one will be divided. So altogether, we have ln of x times x minus 1 over x plus 1 plus c. Okay. Okay, let's do number 8. Number 8. Number 8, the degree of the top is 2 and the denominator is already factored out. So you can keep the way it is written because we know that inside the parentheses, they are already reduced. So x squared minus 5x plus 16 over, no need to write that because they will not be reduced. Okay, so x squared minus 5x plus 16 over 2x plus 1 times x minus 2 squared, we will have 3 fractions. The first one is for 2x plus 1. The second one, since we have the power 2 here, will be x minus 2 to the power 1. And the next one, x minus 2 to the power 2. And the numerators are a, b, and c. So in order to combine them, we would have x squared minus 5x plus 16 for the left side. And for the right side, we need to multiply the first one by x minus 2 squared and also the top. For the second one, in order to have the whole denominator, we are going to multiply this by 2x plus 1, and also we need to multiply it by another x minus 2. The same thing for here. So 2x plus 1 times x minus 2. And for the last one, it's only multiplying by 2x plus 1 here and here. So altogether, the right side will be a multiplied by x minus 2 squared plus b times 2x plus 1 times x minus 2 and c times 2x plus 1. You can either multiply them together, that would be a lot of work, or you can pick some numbers. If you pick some numbers, let's say x equals 2, and when you plug into the left side, you would have 4 minus 10 plus 16, that is 10, equals, for the right side, that would be 5 times c, because you don't have the first one, you don't have the second one, you only have the third one. From this, c is 2. If you pick another number, let's say we have negative 1 over 2, the left side will be 75 over 4. The right side, you don't have the second one and third one, you only have the first one. That would be 25 over 4a. It means that a is 3. And we can pick an easy number like 0. If you plug in 0 for the left side, that would be 16. For the right side, that would be 4a minus 2b plus c. We know that a is 3, c is 2. So that would be 12 minus 2b plus 2. It means that b is negative 1. So the given integral is equal to a, which is 3 over 2x plus 1 dx plus b, which is negative 1 over x minus 2 dx, and c, which is 2 over x minus 2 squared dx. For the first one, you would say that this is a fraction, and if we take derivative of the denominator, that would be 2. So in order to solve this one, we can set u equals 2x plus 1. So du will be 2 dx. We can bring out 3 here. So for 1 over 2x plus 1 dx, following the u substitution, that would be 3 times the integral of 1 over u times, instead of dx, that would be du over 2. And this part will be 3 over 2, the integral of 1 over u du, which is 3 over 2 ln of absolute value of u, and u is 2x plus 1. Okay, this was the first part. For the second part, we can bring out negative and write it as 1 over x minus 2 dx. So we know that this one is going to be ln of absolute value of x minus 2. So we would rewrite it all these steps. And for the last part, we can bring out 2 and we rewrite the inside the integral as x minus 2 to the power negative 2 dx. We know that x minus 2, which is here, have the derivative of 1. So we don't need any derivative outside. It is the same as if you say x minus 2 is u. So I would have the integral of u to the power negative 2 du, which will be u to the power negative 2 plus 1, which is negative 1 over negative 1. And we know that u is x minus 2. So it will be multiplied by negative 1, and u to the power negative 1 is the same as 1 over u, which is x minus 2 plus c. So we can simplify this and write it as negative 2 over x minus 2 plus c, and we would keep all that here. This was number 8. Let's do the last one, number 9. So number 9 is already factored, and the degree of the top and bottom are the same. No, they are not the same. The degree of the top is 2, the degree of the bottom 2 here, 1 here will be 3. So 3x squared minus 2x plus 3 over x minus 1 times x squared minus 1 will be two different fractions. The first one, x minus 1 with a as the top. The second one is x squared plus 1. This is not reducible, and this doesn't have any power for the whole thing. So the top or the numerator will be of degree 1. Okay, so the numerator of the left part is 3x squared minus 2x plus 3. And for the right side, it's enough if you multiply a by x squared plus 1 and bx plus c by x minus 1. So we would have 3x squared minus 2x plus 3, and you can either multiply them together or pick some numbers. Let's pick some numbers here. If you pick x equals 1 for the left side, you would have 4, and for the right side, you don't have the second term. For the first term, you get 2a. It means that a is equal to 2. Another number can be 0. For the left side will be 3. For the right side, if you plug in 0, you get 2 minus c. It means that c is negative 1. So the given integral will be equal to a, which is 2 over x minus 1 plus the integral of bx. Okay, we didn't find b yet. So we know that for all these here, we can plug in numbers, or you can say since the coefficient of x squared on the left side is 3, and the coefficient of that of the right side, if you multiply these together, And also you have a here will be a plus b. Since we know a is 2, we can say b is 1. Or you can pick some numbers for that. So the next integral will be bx, which is x, because b is 1, plus c, which is negative 1, over x squared plus 1. We know that we cannot reduce the denominator here. So we can bring out 2 here. So it will be 1 over x minus 1 dx. And for the second one, we can write it as x over x squared plus 1 minus the integral of 1 over x squared plus 1 dx. So the first one is 2 ln of absolute value of x minus 1. And the second one, since let's do it this time with another way or a faster way. We know that the derivative of the denominator, which is x squared plus 1, is 2x. So if we have a 2 here, the answer for the integral will be ln of denominator. But we don't need, or we are not allowed to change the question. So we would write 1 over 2 here to compensate for that. Using this, we are going to have 1 over 2 ln of absolute value of x squared plus 1, which is always positive here. And the next one will be minus tan inverse of x, because we have this one in the table, plus c as always.